the simplicity of the um, aquarium aerator is quite fascinating, and it's always been interesting looking at how it works, so I thought I'll just share the working with you. So when you flip I've already removed the screws. When you flip the aerator and remove the back case, this is what you find inside. And inside, what you'll find is this is an aerator with two chambers, two air outlets, and you have a rubber cap which is mounted on a clamp, and you have the magnet at the other end. Here you see the electromagnet, which makes the magnet vibrate at a certain frequency, and the alternating current works at a certain frequency, and this is the frequency that gets the magnet activated. So every cycle you have one vibration of the magnet, and here they've kept a very simple mechanism to control the intensity. Let me see if I can. This is a switch, a simple switch which has got a diode built in, and once you pass it through the diode, half the frequency is cut. So for example, if you have 50 hertz as your alternating current frequency, and that will be a sine wave which goes up and down. When you pass it through the diode, only half the wave comes through, which means the intensity gets reduced by 50%. And if you remove the rubber cap, I've dislodged one of the pumps to show you the valve structure inside. It's a very simple mechanism. Here you see the inlet valve. So this is the flap that opens, letting in the, I'll just open up the valve manually. So that is the inlet valve, and underneath you have the exit valve. That's a stopper, and it's just a small flexible piece of rubber. And the black piece is actually a stopper that keeps the valve firmly in place. This is all there is to the chamber. Here is how the system works. As we saw, there are two valves inside. The inlet valve, which sucks in air through this hole, and the outlet valve, which pushes air out through here. First we have the compression. So when the magnet moves down and the rubber gets compressed, the inlet valve, since it is over the hole in the chamber, it cannot open. The air presses against the valve, and the way out is through the outlet valve. The outlet valve opens outward, so it is easily opened when the air is pushed out. And when the rubber expands, there is the suction, and when air gets sucked in, the inlet valve opens because it is opening into the chamber. The air enters through this hole and fills the chamber. But since the outlet valve is opening outwards, it gets sucked onto the hole and the hole closes, so air cannot enter the chamber. So that is how the cycle continues. So compression, outlet valve opens, air goes out. Expansion, inlet valve opens and air is sucked in. And this happens as a cycle, pumping out air. I'll just switch on the power so that you can see how the system works. So here you can clearly see the magnets vibrating, and you can almost see it's too fast, but you can see the cap vibrating, and you can feel the air coming out through the nozzle. So if you let me try to keep something there. Now for the theory part of the working. Alternating current is normally in 50 hertz or 60 hertz. Some countries you have it at 50 hertz, and other countries you have it at 60 hertz. Let's look at a regular sine wave which forms an alternating current. A full wave is from the start to the finish of the waveform, and on the wave you have an upper peak and a lower peak, which forms the full cycle. The upper peak and the lower peak are opposite in nature, which means one attracts the magnet and one repels the magnet. So a full cycle has one attraction and one repulsion of the magnet, which forms the full throttle of the power. Once you put a diode in, which is theoretically represented like this, the diode lets the power pass only in one direction, which means half the wave will be cut off, and the performance of the magnet gets reduced by half. So here you have just the upper part coming in, and the lower part, since it does not exist, the magnet does not